All right, so this is going to be part 2 for the systems of equations. I really just have one thing to show you. This won't take long, so it's a nice short video for you. As you can see, I picked up right where we left off. This is the equation we worked on last time, where we found x equals 9 and y equals 5 by using the substitution, elimination, linear combination, whatever I decide to call it of the day. All right, whatever that method is. So now, here's one. This one looks a little different than the one we just did. Simply because if you notice, let's take a step back. Notice we still have 2 x's and 2 y's, okay? We have no coefficients of 1, okay? So like we did last time, we can't come up here and use the substitution method. Well, I'm sorry, not to say we can't, it would just be really difficult, okay? You'd have a lot of fractions, and we all know that no one likes fractions, okay? So we're gonna skip that method, and we're gonna go back to the elimination method, all right? So we're going to follow the same steps. We still need to get rid of one of our variables because we need to solve for something with just y or just x. Now here's the problem. I can't just multiply a number here times, let's say, the top equation. There's nothing I can put out here that when I distribute to 2 that will make me a 3. Okay? At least a whole number. Or when I distribute to -5 will give me a 4. Alright? We can't do that. So what we're going to have to do instead, as soon as I get the eraser to work here, is we're going to have to basically modify both of these equations, all right? Now, it does not matter which variable you start with. You can deal with the x's or the y's. It really doesn't matter, okay? Now, here's my suggestion. Again, this is just my suggestion, all right? I suggest, if I can get this pen to work, all right? I suggest that you use the variable, all right? Use the variable that has a positive and negative. It has a plus and a minus, okay? I suggest you do that. Only because it saves you one less step, all right? So, and I'll readdress that again in a second. So, let's see. Let's use the y in this case, because notice we have a minus y and a positive y, okay? So we're going to use the y here. And I'll color code this so we can kind of keep it separate a little bit. If I get the eraser to work, there we go. All right. So here's the question we have. Up here we have a 5y, or a negative 5y, and a positive 4y. So we have a negative 5 and a positive 4. So the question is, what do these two numbers have in common? Okay? Now, really what you want to do is find the least common denominator that they have between the two numbers. But you can always take the easy way out, and you can just simply do this. All right, well, let's take 5 times 4, which gives me 20. Okay, so we can always say, all right, they both have the number 20 in common. So, in other words, our ultimate goal is going to be to get this. Watch. We're going to want to get some x minus 20y equals something, and we're going to want to get some x plus 20y equals something. Because, I'm going to skip ahead here again. So when we get to this step here, when we add the two equations together, you can already see that when you take these two numbers and add them together, you're going to get 0y, okay? And that's the ultimate goal here, okay? We want to find two numbers, we want to make them the same number so that when we add them together, they'll cancel each other out, all right? So now, we simply have to ask pretty easy question here, and the question is, what times -5 will give us this -20 that we so covet here, all right? And the answer is pretty simple. It's going to be 4, all right? I'm sure you already know that. And we do the same thing for the bottom one. What times this 4y will give us our 20y? And the answer is going to be 5, okay? Now, again, the reason I suggest using one that's already plus and one that's already minus is because if you don't, you're going to have to come back and make one of these negative or, whichever one, so that way you can have a positive and a negative, all right? Because, well, again, if you don't have opposite signs, when you add them together, they don't cancel out. So, and again, I'll show you that in class too, so you'll have seen this multiple times by now. All right. Now, you should all know by now, you must use the distributive property every time. And it goes to everything, even the -15 on the outside. Okay? Excuse me. All right. So, let's see. What are we going to have here? We're going to have, I'm on the wrong equation. We're going to have 15x. So, like I was saying, we were going to have 15x. Now, I realized I made a mistake here, so sorry. I went back and checked it for a second. That's supposed to be a -3x. My fault. Which actually, again, like I said a second ago, gives us -15x, all right? And 5 times -15 is -75, all right? Now let's do the second equation. I double check this one too. I'm going to distribute everything to give us 8x. Again, gives us negative 20y, and then is going to give us 40. Okay. Now again, the whole goal here is to cancel a variable out, which is what we've accomplished. Okay. Because now notice when we add these together, I'll write in black this time. We're going to get negative 7x. These two are going to cancel out. Again, the whole point of the entire thing is to cancel one of them out. And 40 minus 75 is going to be negative 35. All right, and we all know how to divide by negative 7 on both sides, which gives us x equals positive 5. Okay? So, not too bad. And you should already know, because we've done this once already, the next step is plug your first answer into whatever equation you want. Okay? You can plug it into either that x, you can plug it into that x, or that x. It really doesn't matter. Okay? You can plug it into whatever x you want. So, don't worry about that, whichever one you want. I'm going to plug it into the first equation, so that one right there. Okay? All right. Sorry for the clicking. If you can hear that, that's my dog. So let's see. That's going to give us 2 times 5 minus 5y equals 10. Okay? And this is the easy part because we multiply to give us 10 minus 5y equals 10. Now watch what happens here. We subtract 10. Those are going to cancel out too to give you negative 5y equals 0. And anytime you have a variable equal to 0, you automatically get 0 for your answer. So there you go. All right. So again, I made this separate video not so we can also so you can re-see the process again, but most importantly so you can realize sometimes you're going to have to multiply times both equations to cancel something out. Because again, there's nothing you can do to one of these single equations that will give you the same number, okay, with opposite signs on one variable. So we had to multiply 1 times 4 and 1 times 5, all right? So now I'm just going to point this out real quick. You could have, I'm going to write this in green on this side. Some of you might have seen the positive 2 and the negative 3 and said, well, okay, I could have just multiplied this times 3 and this times 2 because that would have given me a 6x and a negative 6x, okay? And you would have ended up solving for y first, so the only difference is you would have found that y equals 0, you would have plugged it back in, and then got x equals 5, okay? So it's the same process, just going about it from a different angle, okay? So there you go. This kind of covers everything. Again, this was part 2. This finished off the system of equations using the substitution method. Using the addition method where you just multiply times one of the variable, one equation, and then where you had to multiply times both equations so that you can cancel something out. All right, so I hope this helps so that you've now seen pretty much everything I could test you on, okay? So yeah, so if you have more questions, come see me in the morning, shoot me an email, whatever. All right, just let me know. I will help you as much as I can. All right, thanks.